So on Tuesday, we were working with lesson 1.3, 1.4, and the first page of that activity looked like this. And we left off on the third page, beginning with the definition of polygon. And I indicated that we would come back and continue our conversation with polygon. But I wanted to actually present a little differently, so our presentation is going to be around a PowerPoint. So the purpose of the PowerPoint is to kind of give you an impression of what it is and what it isn't, so that when we get that final definition, you at least have some understanding of what a polygon should look like and what are some of the things that a polygon don't have in terms of characteristics. So we're going to, I'm going to present some different shapes here as polygons, like either on the sheet of paper. You can use one of your handouts, like the 1, 3, 1, 4 would be a perfect example. To the right of those tables, there's some space there. And just write like a Y for yes or N for no if you believe the shape that I showed you, such as this one on the screen now. You think it's a polygon, yes or no? And as we go through and we'll develop a definition. And so hopefully by the end of this part of the presentation, you have a pretty good understanding of what a polygon is and definitely what it's not. So, these are pretty quickly. So hopefully it said the answer is no. You're not giving anything away at this point. How about this one? If it's a polygon, yes or no? Or Y or N? And again, I hope you chose no. But what if I add a third side to it? And how about this? Would you consider this to be a polygon? So hopefully you said yes. How about this one? Again, yes on this one. So hopefully you decided, if you didn't already know, decided that definitely triangles fall into this polygon definition. How about this shape? And the answer is no. So what is it about this shape that makes it a no where the previous three were yeses? And we'll be thinking about this. And how about this one? Okay. Hopefully you said yes on this one. How about this one? And how about this last one? Again, hopefully you said no on the last one. So what is the shapes that were yeses versus those that were no? Every shape starting with the first triangle to the end, they're all closed shapes. What I mean by closed is exactly one region on the inside and everything else on the outside. But the two no's have a curved edge. So the other shapes do not. So even though they're all closed with exactly one region, all the ones with yeses are just seconds. How about this one? This one again is a no, not a closed region, all of these segments. This one? How about this one? Hopefully those said two yeses. Both segments, both I have one region. How about this one? This one here, hopefully said no. A lot will depend on how you look at it. Did you look at the 3D object? And if so, then it kind of looks like a box. But if you look at it as a flat shape, it has 6 edges, 6 sides to it. And so it is made of line segments, but there's 3 regions on the inside. So you have the outline that again has 6 sides, but 3 regions on the inside. So it's a no. This one. Hopefully again, no. Again, if you look at a 3D object, the polygons are not 3D objects, although 3D objects can be made of polygons. But this, if you look at a 2D shape, there are 3 regions on the inside. So here definitely is a 3D shape, so hopefully said no. So I'm going to stop here. It's the last one. And we're going to go back to the handout. So a couple of things we need to know about polygons is that first and foremost, they are made up of closed shapes, line segments. So a polygon is a closed shape with one region that has line segments connecting at the endpoints of other line segments. So, for example, this would not be a polygon, even though the line segments are connecting the endpoints of other line segments. There are two regions. And this would not be a polygon because although there's one region, the line segments are not connecting to the endpoints of the other line segments. So these are both examples of nodes. Two regions, one region, but again not connecting to the endpoints. So I think there are two definitions that are really difficult to define. I think polygon is one of those, and sometimes just spending time and experience with polygons differentiating between the S's and O's helps better understand at least the idea or definition in your head. Starting with here, polygons. If you would list the polygon names that you know, so turn the video off and then write down the names of the ones you do know. Turn the video back on, and then we will complete the table. You need to know for your tests and as well as future problems the special names up through including 12. All right, so the first one, hope everyone knows this one. It's a triangle. Four-sided, we've been using that word for the last couple of days. It's called a quadrilateral. Starting at 5, pentagon. Hexagon for 6. 7 is called a heptagon. Kind of think like September, but an S instead of an S. Actually, one time September was the 7th month. 8 is October. I'm sorry, 8 is octagon. October. October used to be the 8th month. Number 9 is not like Novi, like November, but it's actually nonagon. December used to be the 10th month, because and the 10th shape is called decagon. So the 2 month, the starting with September to the end of the year, the Greek prefix actually is a number prefix, but it's off by 2 because Augustus Caesar added 2 months to make it 12. He added a month for himself called August, and a second month, which is July for Julius. Starting at 11, as well as 12, we will continue with the decagon as part of the name. And what they did was they kind of put prefixes together to get to the number that they wanted. So the decagon is the 10, and then they put a prefix in front of that. That made a 1, and the other one for a 2. So like the card game Uno or Unai is 1, so Un decagon would be 11, it's the 1 plus 10, and then Do decagon would give us the 12, Do for 2, deca for 10. So at the end, it's called engon. And the reason why I'm bringing it at the end is because if you go past 12, instead of learning all these prefixes, we're just simply going to call it a 13-gon, 14-gon for 14 sides, and so on. All right, so for listing of shapes, you can go ahead and read through the paragraph. But basically, if you start at a point and you want to name this pentagon, you can go either clockwise or counterclockwise, and you list the points in order. So this could be listed as A, followed by E, followed by D, then C, then B. That would be going clockwise. If I go counterclockwise, then it would be the name that's listed here. What you can't do is just simply label the points in any order that you want. You must go clockwise or counterclockwise for a specific point. So for example, if I start at A, and I go counterclockwise, I would get triangle ABC. If I would go clockwise, the second name would be triangle ACB. If I start A, then go to C, then go to B. If you would list the other 4 triangle names. Now, once we get past triangle, we will not place a symbol in front of the letters. But for triangle, we place a triangle symbol in front of it because we also use 3 letters for angle, so we have distinguish between the 2. So please list those others. Turn the video back on when you're ready to continue. So if I start at B going clockwise, that would be BAC. If I go counterclockwise, that would be BCA. If I start at C and go clockwise, that would be CBA. And if I go counterclockwise, that would be CAB. So every triangle has 6 names, just like with the rectangles and it's like the segments and the lines, and that we can change the order of the letters. And this order here is not reversing the letters; it's just simply changing the order basically clockwise or counterclockwise. Starting here, the name of the symbol that is congruence, and what does it mean? So go ahead and. If you've not done that, let's draw the symbol and explain it. So the symbol is drawn with like a squiggly little symbol above an equal sign. Each of those have a specific meaning. The first part of it means same shape, or same shape, so they're both like triangles, both angles, and this means equal measurements. So if there's just a segment, we're looking at the same lengths. If we're talking about triangles, we're looking at all the sides, all the corresponding sides that match up are the same. All the corresponding angles that match up are also the same. So we use congruence. So this is where we're going to kind of end. I'm going to do this A, B, C, D, E, and then I'll let you finish this one off on your own, and we'll pick up with our discussion on the last problems on Monday when we meet again. There is, and then on to the next activity, which is lesson 1.6. So you're looking for what shape matches up. You're looking for the symbols. So for example, off of this double angle here, there's a single and a double. And these are both singles, so this would not work. If I jump to the last one, I know there are angle marks here, those 4 angles that are not marked, which is why this one here would not work. So the one that actually, if I turn it and superimpose it on top of the other shape, and the numbers matched up perfectly, it would be the middle shape. So if you didn't choose the middle shape, choose that. I would probably start with letter N, since A is the top, and then I'm looking for the one with the double tick mark, which would be N. And then angle B has the single, and you have 2 choices, and it goes to a right angle. So I'm going to go this way, so I'm going to single to the right angle, so N, P, Q, L, M. And if you actually go the counterclockwise, it would also work. So, there's actually 2 ways to do this one to match up the shapes perfectly. Take a look at how to match up the other 2 shapes by putting one shape on top of the other. Make sure the letters are in the right